So here in this one, if we see it, the original cantilever bent is now converted into a frame with two supports with the addition of a roller support at C. We will examine the effect of sway subjecting the frame to horizontal load at B. To identify the reaction at C, we will remove notionally we will remove it the support. Point C would deflect downwards as a result of the horizontal force at B, and the resulting reaction would be upwards. If we apply the force here, it will move this way, and this point C, this is known load now, so it will bend like this. It will not bend, it will like deflect like this. So C will come downwards, so reaction at C will be upwards. Now we can draw the deflected shape of the being careful to maintain the right angle at B. We need to maintain right angle at B. Okay, so we will maintain right angle at B, and then the C will push it upward. It will be like this because this will be moving horizontally only. There is no vertical displacement because support is there. Na? So it will behave like this, and then this B also it will be coming like this. Here we have this. Here we have this support, right? Here we have this kind of tension here, this side tension and this side bottom fully tension. That's why tension, if it comes here bottom side, we are minimum diagram on the tension side. So because of this horizontal load, point B moves here and C will be moving downward, and horizontally it goes up. When it goes up, we need to maintain the right angle at B, and it goes up, so it will be behind like this, and then here we have the support, so it will bend like this, right? It will bend like this. This is how minimum diagram it comes. We can now draw the deflector shape, being careful to maintain the horizontal reaction HA will balance the applied load. This HA will balance the applied load, and the vertical reaction VA will be opposite to the reaction VC, correct? And there will be an anti-clockwise moment at A. There will be anti-clockwise moment at A, which is confirmed by the tension on the left hand face of the column AB. In AB, we have the left hand side if the tension is there. So the bending moment diagram may be derived from the reactions and confirmed with the deflected shape. The upward reaction at C will cause the sagging moments in the beam BC. So it will cause sagging moment in the beam BC. And we know that there is a tension on the left hand side of the column A, which completes the minimum diagram. So it will be completing like this. Note particularly that confirmation that point of contraflexion the member AB. Okay, so this is how it will behave, this structure. Okay. We will analyze one sample, one typical problem. This problem is nothing but we will fix it here and 5-meter length, and this is 2-meter length. At the middle we are applying a concentrated load, and this one we are restraining only this direction, restraining, that means like a roller support we are giving like this. Okay, so it's a restraint like this. We are giving a problem like this, roller support here and fixed here, and apply load at middle. What would happen because of this load? This joint, these three joints, these joints we know it will not move anywhere. This joint, what would happen, it is, suppose if this support is not there, it will tend to move this way, right? Because of this one, it will tend to move like this. It will be deflecting like this if this support is not there. Since this support is there, this joint it cannot move, so it can move only vertically, and this joint also it cannot move horizontally, so it will try, but it will try to rotate. So it will try to rotate like this, and after this load there is no, after this point there is no load, it will be straight. This will bend, so this will rotate and it will come like this. So there is a point of counterflexure. That means this joint will try to rotate like this, because this joint it cannot move this way, and this joint is fixed. So once it's rotating like this, it will come like this. So there is a point of counterflexure somewhere here and change in slope, and this one, this will bend until like this. After that it will be a straight piece only, because it is there is no load, only horizontal force is there. There is no vertical force. So because of this horizontal force, there will be a reaction moment here. This vertical force will be restrained by this vertical force. This horizontal force, it will be restrained by here. Because of this vertical force and this horizontal force, there will be a moment that's here. So bending one diagram will be looking like, it will be like this, and like this it will come, bending one diagram. Okay, that we will see it here. So I have created 1 2 3 nodes. This is 2-meter beam, this 5-meter column, and this is a fixed support. This is the fixed butt support. If you see here, supports here, it's a fixed butt support. We are arresting releasing everything and arresting only x direction. X direction is, this is the one, x direction. So next one is, this is fixed support, and if you go to the loading, we have applied concentrated load at the middle. So when it is applied here, it will try to deflect vertically only. This joint also it will move vertically. This joint cannot move horizontally, then it will rotate. Okay, so we will see the bending one diagram for this one. So we will analyze this, run analysis. After running the analysis, we will see there should be no errors, 0 warnings. Go to the post-processing mode and apply. You will see here, this is the deflection pattern. You can see the deflection pattern, how it deflects. Here you see, this is tension is this side, here tension is this side. That's why bending diagram comes like this, and when it comes like this. So here we could see, this is the deflection pattern, right? This is the deflection pattern. So in this deflection pattern, this portion becomes tension, this portion it becomes tension, and this here somewhere it is point of counterflexure, no bending, and this is bending only like this after, until the load point. After that it's straight. Okay, so if we see the bending one diagram, it should come like this. From this it will start like this, and it will like this, and it will go like this. That also we will see it here. This is the bending one diagram. See here. Okay. So deflection and benevolent we have seen. We can see the reactions also. 2.994, 2.994. That's horizontal one. Vertical one is 10. So I apply 10 kilometer, 10 kilometers applied by here. This one only. Okay. Reactions. Yeah, Z is 4.97. View results. Okay.